Welcome. Now I'm going to start that very important concept, that is NGP. Okay. Topic is NGP. That is neighboring group participations. This NGP, neighboring group participations. This topic is very important. It play very important roles. NGP play very important roles because this NGP, what it will do, that it will control both rate as well as the stereo of a reactions. The neighboring group participates in a molecules. If NGP is there, then that NGP it controls both rate as well as the stereo. It means that the stereo will be different and that rate will be different if NGP is participating. So what actually means the NGP means that actually in a substitution reactions, in a substitution reactions, a nucleophile within the molecules within the molecule uh, that part in substitution reactions in a substitution reactions a nucleophile within the molecules, okay, that participate temporarily to the reaction centers to control both rate and stereochemistry, that is called that NGP. Okay, that participate temporarily. Why temporarily means that it will participate, then the nucleophile whatever there in the reactions medium that will do. So it actually temporarily participate to control the rate and the stereochemistry. Okay, so that will be clear while I'm taking the I will discuss about examples on that time, that will be clear. So now I'm going to talking about of the definitions, how you define that NGP. It means that a nucleophile within the molecule that participate temporarily or we can write here within the molecules close to the reaction center. So that should be close to the reaction center. Okay, close to the reaction center that participate temporarily to control both rate and stereochemistry of the reactions. Stereochemistry of the reactions. So that involvement is called that NGP, or that participation is called the NGP. Okay, that involvement is called NGP, or that we can say that neighboring group participations. So here important thing is that a nucleophile near to the near to, okay, within the molecule close to the reaction center, and that participate temporarily to control both rate and stereochemistry of the reactions. Okay, that participation, that involvement is called the NGP. So what I mean that, let's say if we have the molecules, okay, if we have the molecule PHS, and let's say this is there, here Cl is there. Okay, so this here we have the lone pair electrons, and this is the leaving groups. So what you see that this carbon atom is the reaction center. This carbon atom is the reaction center. So what this nucleophile will do, it participate temporarily to this reaction center. It means that if we write 1, let's say this is 2 and this is 3, so this will attack here to this reaction center. to this carbon, to carbon number 3 it will attack, and this chlorine will leave. Okay, so what it will form actually, so this is formed as the intermediate. It means this that transition state. Okay, not intermediate, transition state it will form. That is going to be this for S, because lone pair electrons is used, so this get positive charge. Okay, and this become, so 1 2 3 3 member rings will form, and this leaving group has left, so it will form the 3 member ring. Okay, this is 1 2 and 3. So what we will see that whenever the nucleophile attack to that the nucleophile within the molecules, means it is one molecule, so within this molecule nucleophile is present, and that has to be close to the reaction center. It means that this is 3 member rings. Okay, means that 1 2 3. So that close in the sense, close, what I mean that this, so I say that close to the reaction center. What it means that the reactions may be the close to the reaction center, means here the transition state. Okay, the transition state for is always what cyclic transition state will form. Okay, cyclic transition state, and that cyclic transition state that close to the reaction center in it means that this may be 3 member rings, this has to be 3 member rings or 5 member rings, and like that means that the cyclic transition state should be 3 member, 5 members, or 6 member, or 4 members. Okay, that amount of that clause means that whenever the cyclic transition state will form, this has to be either 3 5 or 6, then only that nucleophile will attack. Otherwise, that if it is 7 8, then that nucleophile will not attack. So that will discuss that these 3 member rings which is more stable, on which cases the reactions will be high, that will discuss later. So here what I mean that nucleophile close to the reaction center, it means that that should be close to this nucleophile center, either it may be 3, either it may be 5, either it may be 6, and that's okay. So now, and what I say is that it control both the rate and stereochemistry. So here we have that nucleophiles. So let's say in the solutions we have the nucleophile, let's say CH3. Let's say we have the nucleophile of AC, CH3 COO, that acetone is there. Then what will happen, that this acetone, again this is the CH3 CO minus, this is the nucleophile, again this will attack to this member rings, and this is going to leave here. It means that where this nucleophile it temporarily attack, after that again you see that the same we will get. Okay, so now what you will see that this SPH, and here we will have that this SCO, that again that this group has OSC, sorry, OSC will get. It means that this nucleophile temporarily only involved. After that we see that this nucleophile will attack, which is in the solvent. So that's why you say that, so this nucleophile which is within the molecules, that temporarily only involved in these reactions, and if it is participate temporarily, but it affects the two things, what that nucleophiles within the molecules, what it control two things. One is the rate of the reactions, and secondly what it controls, that stereochemistry of the reactions. So the nucleophiles, what it did that it controlled the two things. One is rate of the reactions, and another is the stereochemistry of the reactions. How it will control the rate of the reactions? Let's say we have this. In this, we are doing the reactions, okay, and here we have these molecules, PHS chlorines, and here we have that solvents, and solvent in that solvent we have ACTO, that is acetone is there. So what we will do that whenever this nucleophile, so what we'll get that this is the product we get, okay, this is the product we have. So what will happen that this ACOH means whenever this nucleophile attack to this, and we have also this that nucleophile, this is also present, that is CH3 C double bond of O minus, this is also present. So attack chances, this also attack, okay, this one also attack to it. So now you tell me that which attack is the past. So definitely this nucleophile attack is the past, okay, this nucleophile attack is past. Reason is whenever this nucleophile know that which is the reaction center, okay, this nucleophile know the where is the reaction center, but this solvents nucleophiles, it has to source that this first substrate, after that it has to source that reaction center, okay, so that it will take time to source that, and then only it will attack it. But in case of the nucleophile which is within the molecules, that know where is the reaction center is, so it easily attacks. So attacking of the nucleophile which is within the molecules to the reaction center is faster than the nucleophile which is present in the solvent. Reason is that that is outside in the molecules, so that has to sort the molecules, okay. So nucleophiles within the molecule easily find the reaction center, and its rate is high. That's because it will attack quickly. Whereas that nucleophiles which is outside the molecules, okay, nucleophile in the solvents, or that is outside the molecules, that has to sort the reactants and the reaction centers, means reactants of the molecules and the reaction center. So it takes time. It takes time, and rate is decreases. Okay, that is definitely that it has to sort fast, then only it will attack. It means that it will take time, so the rate will be decreases. Whereas the molecules within the whereas the nucleophile within the molecules that know where is the reaction center, so it no need to sort the molecules because that is present within the molecules. And secondly, that the reaction center, so it know that because this is only three member, means three member ring it will form, means that three cyclic transition it will form. So it know the where is the reaction center, and it is present within the molecule. So that type of sorting, that things is not there, so the rate will be increased. So what we see that whenever the rate is happening to NGP, then the rate is high. Reason is that the nucleophile is present within the molecules. So what we see that reactions happening by NGP is generally fast reactions. reasons that I already explained. Generally, fast reactions, or I can say that rate is high. Okay. And the stereochemistry. Now, if I talk about of the stereochemistry, so rate, the nucleophile within the molecule, rate of the reactions is fast. Now, the stereochemistry. What we know that? So we know about of the stereochemistry. That if it is a SN1 reactions, then we know that stereochemistry is we will get that racemic product. Okay, if it is SN1 reactions, then the stereochemistry of the product is the racemic product we will get. And if it is SN2 reactions, then we know that we will get that inversion product. That we know that. And what in the NGP what we see? So in NGP, what we have seen that in this case, this is a type of SN2 reactions, because here we have that this is the antibonding, and this nucleophile is attacking in the antibody. That's why this leaving group is left. So it means that this is the SN2 reactions. Okay, this is the one SN2 reactions by the whenever the within the nucleophile that attack. Okay, now the transition state has formed. This is the transition state. Then what will happen that the nucleophile which is present in the solvents, that will attack. Okay, so this is the past SN2 reactions where the nucleophile within the molecule attack. Now the solvents nucleophile will attack to this reaction center, because this is the positive charge. So this has that ring strength. Okay, so this nucleophile will attack here, and this is going to leave. It means that here that again a anti-bonding is there, so that is attacking here, and this is going to leave. So this is again another SN2 reactions. It means that in NGP we are getting the two SN2 reactions. Okay, so what we have seen that, so for NGP what we are seeing, first we are getting that SN2 reactions. So what we are getting NGP, two SN2 reactions. It means first is SN2 reactions, what we will get that inverse product. We will getting that inversion product. Again we are doing the another time SN2 reactions. Then what we will get that first you have this product, and we did the inversions, and again to this inversion we will do that another inversion, means again we get that same this one. Okay, it means that so inversion of a inversion means that same product we will get. So we will get that retention product. What you get here, retention product we will get. It means what I want to say that first we have that A, and we did that inversion, means A dash. Again we did the inversion, means again we will get that A. The same A we will get. Okay, so first A inversions, and again we did the inversion, then we will get that A. So that's it means that in NGP we will do that two type SN2 reactions, and we will get that retentions product. We are getting the retentions product. Okay, so that's what we see that whenever so what we see in that the nucleophile within the molecules that control the two things, rate and the stereochemistry. Okay, so I write here nucleophile within the molecules, means I can write that NGP control two things. One is rate, and in rate what we'll getting is that past rate, means past reactions. It means that rate is high. And secondly, what we are seeing, that stereochemistry. And what are we getting, that either 2 times SN2. It means that what it is, retention in product. We are getting that retention product. This is about of that NGP. Okay, so NGP control 2 things. One is rate, another is the stereochemistry. So rate, we are getting a high rate, means that whenever the reactions are happening through NGP, then that reactions is very chances to occur rather than other reactions, because the rate is high. The reason is that I have explained. And stereochemistry, that 2 times SN2 reactions, and we know that SN2 reactions means inversion product, and inversions of another inversions will be that retention product. Okay, so this is about of that NGP. And this point also, you know that the rate of enhancement, the rate of enhancement by NGP is called anicomeric assistance. So sometimes this word also used, that anicomeric assistance means the rate of enhancement by the NGP, that we called that anicomeric assistance. Okay. Now what we talk, that we talk the examples, and we will see that how the rate is high, how the stereochemistry. So to get more clear, we will look some examples. Okay, so let's start with the past examples. Okay, so let's take the examples. So in these examples, what I have seen, that this I solved already. So here what I have seen, okay, so here that this is the nucleophile that is within the molecules. So first this is happened through the NGP region, that nucleophile there within the molecules. So what it will do, that it will attack to this antibonding of this leaving groups, and this leaving group leave. After that, what will that, I have already explained this one. Okay, this will happen, and this is going to positive charge because nucleophile is attack here. Now that in the solvents we have that this CH3 acetic acid is there, that is going to negative charge, because we know that H will leave, that dissociate. So this is nucleophile is present. So this nucleophile, what it will attack to here, and this is going to leave here. So what we will get, that we will having the molecules, that again that SPH, and here we have that OAC. So what we have seen, that wherever that that leaving groups has left in this side, the same side that nucleophile has come. So here what we seen, that the stereochemistry is retentions product, and what we seen, that the rate, so this is happening through the NGP, so rate is high. So this is happened through a past reactions. Okay, so that we have seen here. Now I'm moving to that next examples. So in this case, now this is a cyclic groups. So I have told that whenever you see the cyclohexanes, this actually exists in the chair form. So first our work is to convert this into the chair form. Okay. Now what we have seen that this is in the down and this is in the above. So OAC is above. So I will put that OAC above here, and this OTS is the down. So I will put here OTS. This one OAC means COCH3. Okay, now what we'll do that. So whenever cyclic forms, okay, that's so what we see in that whenever in the cyclic, this is the case of acyclic cases. Wherever I discuss about of this SPH, this is the acyclic cases. So you know that acyclic cases, SN2 reactions will happen. That will backside SN2 reactions, back nucleophile attack backsides. But if it is a cyclic groups, okay, so let's see that this case. And let's say here we have that OTS and here we have that SCO. So in this case, this is in the cyclic state. So what do you know that? First convert this into the chair form, because cyclohexanes actually exist in the chair form. So convert into the chair form, and OAC is in the above. So put it in the above sides. That is OCOCH3. And that OTS is in the downside, so put it in the downsides. Now what we'll do that here we have that antibody. So what we see that if it is a cyclic state, that I have explained in the case of whenever I was discussing pinnacle rearrangement or stereochemistry of semi-pinnacle rearrangement, what I have told that in the cyclic if it is a cyclic ring and there we are doing SN2 reactions, then what we need that on that case, since this is the rigid systems, okay, cyclic is a rigid systems. So here that backside attack, it means that backside attack is not possible. So for backside attack, for cyclic transition state, SN2 reactions means nucleophile attack backside of leaving group. Okay, so that is cyclic transition state. So backside attack for the cyclic transition state means we have to look that anti-periplanar relationship. Anti-periplanar relationship between the leaving groups and nucleophile, because this is the cyclic transition state. Okay, so for cyclic transition state, since this is a rigid system, so the backside attack of nucleophile we will look in the anti-periplanar relationship between leaving groups and the nucleophile. So what I mean that actually I have already explained that things. So if it is that groups, then anti-periplanar relationship means what I have told that antibonding of leaving groups and bonding of nucleophile should be parallel to each other. Okay, so that is what we mean by that anti-periplanar relationship between the leaving groups and the nucleophile. So what we have seen here in this case, OTS, this is the antibonding of leaving groups, and here this is the nucleophile. So this one and this ones are parallel because this and this, so they are parallel to each other. So these nucleophile electrons will give to here. Okay, and this OTS will be leaving. So they are this nucleophile and this one are the anti-periplenar relationships. So that's why this will attack here. But if they are not in anti-peripheral relationship, that reactions will not happen through the NGP. Let's suppose if I say, if it is like this. Okay, the two cases I am discussing about of it. This case, here we see that here we have that ACO, and here we have that leaving groups OTS. But other case, let's say that ACO is OTS is the in this sides. Okay, this is the OTS and ACOs is in this side. So in this case, what we have seen that here this and this nucleophile electrons, they are the anti-periplenar. They are anti-periplenar relationships. Anti-periplenar relationship. But in this case, the nucleophile and the leaving groups, here what we seen that this anti-bonding will be in these sides. Okay, so and the nucleophile is here, and nucleophile, this is this directions and this is this directions. So they are not planar, they are not parallel. This and this not parallel, not parallel. But here what we see that this and this, so they are parallel to each other. So here they have that, and here they have the anti-periplenar relationship. It means that leaving groups, anti-bonding of leaving groups and the bonding of nucleophile, they are parallel. But in this case, what we have seen that this and these are not parallel. Means one is this group is this side and this antibody is this side. So this and this, they are not parallel. Okay. So what we seen that here they are not in the anti-periplenar relationships. Here no anti-periplenar relations between leaving group, between anti-bonding of leaving groups and nucleophile. But here there is an anti-periplenar relationship between the anti-bonding of leaving groups and nucleophile. So here they have the anti-periplenar relationship. So in this case, this will happen through the NGP. This happened through NGP, but in this case, no NGP. Okay, the reasons I have told that here that they are not in the anti-periplenar relationship. So to occur to NGP for the cyclic transition state, that nucleophiles and antibonding of leaving groups should be in the anti-periplenar relationship. Then only that will occur through the NGP. Okay. Now the questions will come that in that pinnacle rearrangements, on the time what we are discussing that if the group is like this. Okay, here we have that, let's say leaving groups or TS, and in the case of pinnacle rearrangement, what I have told that if OT is that this direction, this is the antibonding of leaving groups. On that time, what I told that, sorry, OT is this, not this direction. If OT is in this directions, okay, then antibonding will be in this directions. Antibonding will be in this directions. On that time, what I said that if we have that, then what I says that for this case, for this antibody, this is the parallel. So this will attack here. So that I have told that in case of pinnacle rearrangement. Why this is attack? That the reason is that here also we have that some groups like OH. We have that OH. That's why this is attack. Reason, whenever it will attack, that positive charge here, we are getting the positive carbonyls. Here we are getting the carbonyl, and that carbonyl is stabilized by the Clausen effects. That's why this has attack to this. So what I mean that In pinnacle rearrangement, if that leaving group is in this position, this means equatorial position, then antibonding is this side, and to this antibonding the parallel is these groups. So this has to do, this was attacking the, that was attacking. But in this case, in case of that, here what we have seen, that this will not attack here. Reason is that here SUO is there, and the carbocation will forms that not stabilized by these groups. Okay, because this is the this is going to be OCOCH3. This is again going to be destabilized, so that's why this will not attack. But in this case, whenever the carbocation, whenever it will go to here, there carbocation was forming, and that carbocation was stabilized by the Plossum effect of OH groups. That's why this this was used to migrate on that case. Okay, so don't confuse about of it. While I am discussing pinnacle rearrangements, that what I say, that if these two things are there, okay, if living group is here OTS and living group is here OTS, then what I say, that if living group is here, and on that case any groups, this is to attack here, and if that living group is here, this is the living groups, this is the living groups, if living group is here, then this group is to attack. The reason behind of it is that on that times we have that OH is there, OH either here also was there, or OH also if it is present here, so that OH will stabilize this carbocation. That's why this was attacking these groups. But now in this case that things is not there, so here only the OTS is in these sides and living nucleophile is in these sides, then only that will attack. Okay, but if that living group is in this equatorial position, on that times this will not attack. Reason is that here the carbocation is not stabilized. Okay, that is the reasons behind that. Whenever I discussing about of that semi pinnacle rearrangement, on that time I used to attack this one also if the living group is here. But in the case of that NGP, okay, NGP case, if living group is in this that is axial positions and the nucleophile is also axial positions, then only that is to attack. But if the living group is equatorial positions and the nucleophile is that axial position, then this will not attack, as well as this will also not attack. The reason is that here if it will attack, then here carbocation will form and that will not stabilize by this SUO, so this will not attack here in the case of NGP. But in case of pinnacle rearrangement, on that time here we have that OH and that is to stabilize the carbocation, so that's the reason this also is to attack in case of pinnacle rearrangement. But in case of NGP, this will not attack. Okay, so that is the simple reasons why I used to attack there, but not now. Okay, so now moving to the questions. Okay, now moving to these questions. So now in this example, so we look here. So in this case, what we have seen, that they have this OTS in this side axial positions. Okay, axial, and this is also axial, so this will be the anti-peripheral relationships, so it will attack here. Okay, and we will get that, we will get this. Here we have OTS will leaves, means that this is going to attack, actually this lone pair will attack. Okay, so what we will get, that here O and OCOCH3, and that is going to attack here, means this ring will forms and this is going to leave here. Okay, so what we'll get now, so here we have OCOCH3 and this is going to forms. Now what will happen, that in the solvents we have this SUH, so that will attack now. SEO, so this is going to attack, and this attack, we know that whenever the nucleophile will attack, they always try to attack in the axial side, because that axial attack is always preferred. So this is attack to this axial attack will happen. Okay, axial attack, and this is going to leave here. So what we'll get now, So here we have that OAC, and this axial attack means again here we are getting that OAC. So this is going to be the product, and if you convert this into the cyclic forms, then what we'll get here, then cyclohexane form. So OAC is the above side, so we can make that in above OAC, and this OAC is the down. Okay, this is 1 2, so here we will have that OAC. It means what we'll get, that retention product. Okay, so we have this one, so we'll get again OAC is in the sides and OAC in the side. It means that wherever the leaving group has left, on the same side nucleophile will attack, so we will get that retentions product. Okay, so it will happen through NGP, and this reactions is passed because that within the molecule nucleophile is there that has attacked, so retention product we will get here. Now moving to the next questions. Okay, so in this question again convert this into the chair form, but now what we seen that this and this both are in the above, so what I will make that OTS is in the OAC is in the above sides. Okay, and this OTS also in the above side. It means that here now what we seen that the antibonding is in this directions and OS is in this direction. So here we see that there is no anti-peripheral relationship between the nucleophile and antibonding of the nucleophile and the leaving groups. So here what we see that no anti-peripheral relationship between nucleophile and leaving group. So what happened here, then no NGP. Here we will not get the NGP. Okay, so for NGP there should be nucleophiles and that leaving group there should be anti-peripheral relationship, then only NGP will occur. Okay, but in case of semi-pinnacle rearrangement or pinnacle rearrangement, if they are if then on that time also we need that anti-peripheral relationship, but that okay, this is the point. One thing is that this is the point, and also the easy way to understand is that leaving group has to be at axial positions. Okay, leaving group and nucleophile has to present axial positions to occur NGP. Okay, so this is the one of the easiest point to understand that where NGP occur or not. Okay, if leaving groups and the nucleophile both present at the axial positions and adjacent to each other, then only NGP occur. Okay, so this is the points regarding of the NGP. But we see that the leaving groups and the nucleophile should be present at axial positions and they should be adjacent to each other, then only NGP will occur. Whereas for pinnacle rearrangement, if both are not at the axial positions, then also that pinnacle rearrangement or semi-pinnacle rearrangement occurs if they are not axial positions. But for the NGP, leaving groups and nucleophile has to present at the axial position and they has to be adjacent to each other, then only NGP will occur. So what we see in that here, what we see that one is at the axial and one is at the equatorial. So here no NGP will occur. So for NGP, what I've said that leaving groups and nucleophile has to present at the axial position. Both should be present. Okay, both has to present axial positions.